For those who don't know me, my name is Matt Morehouse. For the past year and a half now, I've been working to improve the security and stability of the Lightning Network. And one of the things I worked on last year mostly was fuzz testing the Lightning Network. And that's what I'd like to talk about today. So if you don't know what fuzzing is, you should. It's a very valuable testing tool that every software engineer should have in their toolkit. And I'm not going to go into details about how it works or that sort of thing, but there's plenty of resources out there. So go ahead and take a look and start using it. But as with any software, the reason we would want to fuzz the Lightning Network is to find bugs. And Lightning Network bugs are especially bad. Of course, as with any software, bugs provide a bad user experience. But with Lightning specifically, there's money at stake. And if you can't send payments to buy your groceries or whatever, then you're probably not going to want to use Lightning anymore. And things can be worse than that. In the traditional payment system, for example, credit cards, if there's a bug in the software and you get charged something you didn't actually buy, you just call up your customer service and you tell them what happened, and they can fix things on the back end. But with Lightning, there's no fixing things. If your node glitches out and sends twice as much as you wanted it to send, or it burns a whole bunch of money as fees, you're kind of out of luck. So it's extra important that we make sure that these bugs don't exist and that we fix them when we find them. In addition, Lightning has this unfortunate property that nodes need to be online in order to protect your funds. If a node is not online with some amount of regularity, what can happen is your counterparty can broadcast a revoked commitment, and you won't be able to notice that in time before they can then permanently claim those funds. So they could potentially steal your entire channel balance. And this can also be done using HTLCs. If there's any HTLCs in flight when your node goes offline, once the time locks on those HTLCs expire, the upstream node can claim the HTLC via the refund path, and the downstream node can claim it via the pre-image. And so they can steal HTLCs that way if your node is offline for too long. And so basically for Lightning, any sort of DOS vector becomes a fund stealing vector. And it's especially important to fix any sort of crashes or anything like that for Lightning. So that's why fuzzing is so important. We need to find these bugs, we need to fix them. And I have a couple examples to talk about bugs that fuzzing has found for Lightning specifically. First, we have CLN invoice parsing bugs that existed prior to 23.11. These were all bad things that happened when you tried to pay certain invoices. Your node might crash, it might read on uninitialized memory, you might have a buffer overflow or other undefined behavior. And all these bugs were found by a single fuzz test that Nicholas Gold wrote and that I hope to improve. And it's a great fuzz test, and it found a lot of bugs. This particular bug or set of bugs is not super concerning from a security point of view, because if you pay one of these buggy invoices and your node crashes, as long as you can restart your node and make sure you don't keep paying invoices from that person again, then you don't really have any worry about your funds being lost. Maybe in some unusual circumstance, you could have funds at risk if your node is remote somewhere and you aren't able to get access to it to restart it or something like that. But I think by and large, this is more of a bad user experience and a griefing vector rather than a less major security risk. But other bugs are a lot more serious. Yesterday, I disclosed the LND onion bomb, which was a vulnerability in LND prior to 0.17, where any LND node could instantly be crashed by sending it a malicious onion packet. And the source of the attack was trivially concealed because it took place via onion routing. So the attacker didn't need to connect directly to the victim at all. You'd have no idea where the attack was coming from as long as there was a path from the attacker to the victim within the Lightning Network. They could crash your node. And this was discovered by a very simple fuzz test. I think it was less than a minute of actual fuzzing. So these are the sorts of things that are really scary. You know, this bug could have totally taken out the majority of the Lightning Network, could have kept it offline for indefinitely until everyone upgraded their nodes. And you know, while everyone's offline, funds could have been stolen too. So these are the sorts of things that we don't want to happen in the Lightning Network, and we want to make sure all these bugs are found and fixed as fast as possible. So with all that said, how are we doing? How is Lightning fuzzing going right now? To be honest, I don't think it's going very good. There's a lot that could be improved. There's not a whole lot of buy-in from maintainers. The past couple of years have been pretty stagnant outside of a couple contributors. So I'll talk a little bit about each implementation specifically. LND, the most popular Lightning node currently, I've heard 80 to 90% of the network runs this. When I started contributing to LND a couple years ago, they had 58 basic fuzz tests that, you know, encoded and decoded various Lightning messages. And as far as I'm aware, it's actually, these tests had found some important bugs in the past and allowed them to fix them before they became problems. But unfortunately, a couple years ago, when I started looking at LND, none of the fuzz tests actually worked. They were all broken. And what had happened was LND was relying on a fuzzing library that was no longer maintained and that was no longer compatible with newer versions of Go. And so none of the tests would run anymore. And also, they didn't have a public corpus. And what this, in fuzzing terms, the corpus is the set of inputs that the fuzzer has found that it considers interesting because it's exercised new coverage or it found a bug in the past or something like that. And not having a public corpus is not the end of the world, but if you make it public, it helps outside contributors a lot because instead of having to start from scratch, they can grab the best known corpus and they can start fuzzing from that. And it could save them weeks or months of fuzzing time. And it's just good practice if you want the best possible fuzzing coverage and if you want to encourage contributions from outside. So last year, I did my best to try to improve the situation with LND. I fixed those fuzz tests that were broken. I set up fuzz regression tests in CI and a public corpus that the regression tests would run on. And this is basically to make sure that the fuzz tests don't break again. If they do, then the CI will turn red and it can be fixed quickly. Also wrote a lot of fuzz tests. There's almost double the number of fuzz tests today that there was a couple years ago. But unfortunately, no one else has really contributed to LND in a major way. So that's not great. But CLN has been very similar. A couple years ago, they had 11 basic fuzz tests. 4 of them were useless, either because they crashed immediately when you tried to run them, or because they weren't actually fuzzing what they were supposed to. But nobody had actually measured the code coverage for those fuzz tests. So they didn't realize that it wasn't executing the code that they thought it was. And CLN also didn't have a public corpus. But I fixed up those broken fuzz tests, and I set up CI and a public corpus for CLN too. So hopefully some of those things won't happen again, and wrote a whole bunch of new fuzz tests. There's 70 today. But again, no one else has really helped much. I know Nicholas Gogue wrote that invoice fuzzing test, and that's a great one. But outside of that, I don't really know of any new fuzz tests written by anybody. And CLNs had also had additional issues with maintaining the fuzz tests. So on one occasion, they were trying to change some things with how CI was configured, and they accidentally disabled UBSAN on all the fuzz tests. And UBSAN is the undefined behavior sanitizer. It finds a whole class of bugs specific to C programs, and it's important to run with fuzzing. But there were months where UBSAN was disabled and nobody knew, and it actually caused some bugs to be missed. When Nicholas submitted his invoice parsing fuzzer, it actually found several bugs if you ran it with UBSAN, and it would have been immediately obvious if UBSAN was running in CI, but since it wasn't, those went undetected. And on another occasion, one of the fuzz regression tests started to fail, and the maintainer got frustrated. Instead of trying to fix the test, they decided to disable all the fuzz regression tests in CI. And that's not great, because the regression tests are there for a reason. And if you get rid of them, then you don't find bugs as fast as you normally would if they're reintroduced. So I tried to explain it to them and got it reverted. But both of these issues, I don't know what would have happened if I wasn't there to notice them and try to fix them. I don't know if the maintainers would have eventually been able to find out and figure it out, fix it on their own, or if it just would have went on and the fuzz test would have bit rotten again and we would have had fuzz tests that didn't work anymore or something like that. So this is a concern I have, not just with CLN, but with all the implementations in general, is there's not a whole lot of buy-in from the maintainers to, really maintain these, improve fuzz tests and that sort of thing. It seems to be driven a lot by outside contributions. Moving on to AAIR. I haven't contributed to AAIR, but I think there's a lot that could be done there, because they really don't have any fuzz tests. They have a few tests they call fuzzy tests that are basically have some RNG inserted into the test to randomize some aspect of it. But they don't have any modern fuzz test that uses a coverage-driven mutating fuzzing engine. Now, AAIR is written in Scala, which doesn't have the best infrastructure for fuzzing. But there are things like Jazzer that you can use to fuzz JVM-based languages. And so I think if someone were to look into this, there might be a lot of bugs that could be found. I also haven't contributed to LDK, but LDK's been doing a pretty good job on their own. They have 60 basic fuzz tests, and then they have 3 state machine fuzz tests that are more advanced than anything any other implementation is really doing. What these do is, instead of like a normal fuzz test where you generate a random input, you give it to some function and see what the function does, with the state machine fuzz test, you actually generate a random sequence of events, and then you execute these events on the node and put the node through different states and make sure it doesn't crash, make sure that things remain consistent, and that horrible things don't happen, like you lose your funds or something like that. And I've been told that these specific fuzz tests have found some important issues in the past. So it'd be cool to see more stuff like this with other implementations too. LDK also runs their fuzz tests in CI. They set that up on their own. And they actually have continuous fuzzing being done at Chain Code Labs. And this is continuous fuzzing means that as the code changes, as commits are made, the latest code is constantly fuzzed in the background. And this is really good because it finds new bugs much quicker than if you're only running your fuzz tests intermittently. And sometimes certain bugs take a lot of CPU time to actually find. And so if you've always got them running in the background, then you're more likely to find these rare bugs. So of course, Chain Code Labs maintains their own private corpora. You need to do that to do continuous fuzzing. But Matt Corallo said he also maintains corpora himself, and he will run the fuzz test for an extended period of time before each release, update his corpus and that sort of thing. Again, I'd like to see public corpora, but it's not the worst thing in the world, and hopefully we can work on that in the future. But also with LDK, there really hasn't been any major contributions the past couple of years. Just basic maintenance of the existing fuzz tests, no major improvements, no major new fuzz targets added. So in summary, the state is not that great. There's not a whole lot of investment by node maintainers the past couple of years. Some maintainers don't really know much about fuzzing or the best practices. And there's very few outside contributors. It's really just me and Nicholas that I've noticed. So we really need help. If someone's interested in this, there's definitely a lot you can do to contribute. I have a few ideas. Some are easier than others, and I can talk about those a little bit. I'd like to see continuous fuzzing for all the implementations. LDK has their own thing, but I'd like to see it for LND and CLN too. This is just a good fuzzing practice to have. You find bugs quicker. It ensures your fuzz tests are used and constantly running. And an important aspect of this is to have coverage visualization so that you can tell what parts of the code each fuzz test is executing, and you can make sure things are working as they should, but also it gives you ideas how to improve a fuzz test to execute new code, or how to write new fuzz tests that would execute a part of the code that isn't being covered. And these are all things that are very useful for fuzz testing. So if someone's interested, there's probably a lot of work that could be done to set up some sort of continuous fuzzing solution for the different implementations. Again, AAIR has no fuzz tests at all. So if someone is interested in looking at Jazzer or something like it and setting up the infrastructure needed to start running those fuzz tests, I think that could be very fertile ground, finding lots of new bugs in AAIR. I'd also like to see more differential fuzzing. And what that means is you generate an input and you give the same input to multiple different implementations, and then you check the outputs. And if any of the outputs differ, then probably there's a bug in one of the implementations. And Lightning is very well suited for this sort of fuzzing because there's 4 different implementations. And so things like invoices or commitments, the nodes all need to agree on it. If they disagree, there's problems. So, an invoice differential fuzzing would look like a fuzz test that generates a random invoice, gives it to all the different implementations and has them parse it, and then compares how they interpret the invoice. And if there's differences, there's probably a bug in at least one of the implementations. Likewise, commitment transactions, given a set of parameters for a channel and a set of HTLCs that are added or subtracted from the previous commitment, every implementation needs to generate the exact same new commitment. And if they don't, then they can no longer interoperate and force closes will happen. And force closes are a major complaint on the Lightning Network. So anything we can do to reduce them is going to improve usability and make operators a lot happier. Finally, this one's LND specific, but LND actually uses some third-party library to do all their elliptic curve operations, and it's written for some random cryptocurrency, and I don't really know if I trust it or not. I've never heard of Decred before, but I'd like to see differential fuzzing between that library and something like libsecp that is more widely used or trusted, and see if there's any differences between those, because if there is, that would be potentially a major problem. More ideas. I like to see more state machine fuzzing like LDK has. Lightning has all kinds of state machines that could be fuzzed. When you open a new channel to someone, there's a whole bunch of states that happen there where you're negotiating parameters for the channel, you're creating the funding transaction, exchanging commitment signatures, waiting for the funding transaction to be published, all these sorts of things. And and disconnects can happen while that's going on that would change the state. And then there's reconnect logic and stuff like that. This is all things that could be fuzzed and things that we want to make sure you can't cause a crash by putting things into a weird state. And with the new dual funding protocol, there's a whole new state machine that's even more complicated that could be fuzzed. As mentioned before, commitments need to agree between implementations, but also there's a whole bunch of state maintained within each implementation to update commitments as HTLCs are added or removed, as fees are updated, or in the future, there's going to be this dynamic commitment thing where you can actually change the entire commitment transaction format. And, as all these things are happening, we need to make sure that things don't crash, that you don't lose funds, that sort of stuff. Splicing also has a fairly complex state machine because while the splice is in flight, and so between the point where the splice transaction is broadcast and it's received some number of confirmations, your node actually has to maintain two different states. It has to remember the state before the splice and after the splice. And any HTLC that is offered to your node needs to be valid on both of those states. Otherwise, it has to be rejected. And so there's a lot of extra state and things to keep track of with splicing. And I think there could be potential bugs in that. On-chain resolution has all kinds of states as well. It starts when your node detects a force close, a commitment was broadcast to the mempool. And now your nodes, maybe that commitment confirms, maybe something else confirms, it doesn't really know. And maybe your node wants to fee bump that confirmation because deadlines for HTLCs are coming up. So it might spend an anchor output on that commitment. And then as deadlines approach closer, then it might want to fee bump. And all these are different states. There's more states after the commitment is actually confirmed because now there's all these time locks that need to expire before your node can then sweep funds, whether it's second stage HTLC transactions that need to be broadcast or your local balance that can be swept after a time lock. Some nodes do more complicated things like trying to batch multiple HTLCs into the same transaction. And so those nodes might actually wait a little bit after a time lock expires so that they can batch multiple HTLCs together. All these things add complexity that can hide bugs. There's state involved with the network graph as your node gets gossip about new nodes, new channels, channel updates. All those things are going to change the state on your node. And of course, watchtowers. A watchtower needs to stay in sync with your node or it's going to be useless. And so as your node is streaming events to that watchtower, you don't want it to crash. You don't want anything wonky to happen because then the watchtower is not going to serve its purpose anymore. So these are some of the ideas I have that we could do more fuzzing of in the future, but we really need more contributors. It'd be good to have more buy-in from maintainers. If they could start working on fuzz testing their own stuff, I think that'd be great. And but yeah, that's kind of the state of where we're at. And I think we have time for questions if you guys have any to ask. Yeah, Fabian.
Yeah, I'm interested if you know if you got feedback from the maintainers why there's not more buy-in from them, or if you have ideas, because I mean that seems like the much bigger lever to achieve like the next step. Like outside contributors that don't really know the code base would need quite a lot of startup time, and I mean these Lightning implementations mostly are VC funded companies that probably could fund someone or pay someone to do this. So yeah, where do you think is like the what's missing basically?
Yeah, it's hard to know exactly. I think so. My theory is that for a long time, Lightning has not been very security focused. It's all about, you know, the new features that are being developed, and so some of this stuff gets kind of pushed to the side. And it makes sense to some degree because, you know, you got 4 implementations, they're all competing with each other. You know, CLN has dual funding and splicing now, but L&D doesn't. And so we got to work on that. Or, you know, LDK is working on the next big thing, you know, route blinded paths and Bolt 12. And I think there's a little bit more emphasis on trying to reach feature parity or to develop the next new feature that's going to get more usage on your specific implementation. Yeah, and there's just, I mean, I think some nodes just don't, the maintainers just don't have a lot of knowledge about fuzzing either. You know, like, I don't know what AAIR has done about fuzzing, but they have no fuzz tests, so maybe they don't know anything about potential JVM fuzzing solutions, or maybe they don't know much about fuzzing. But I do agree. I think if we can get more buy-in from the maintainers themselves, that it could really help improve the security here. And hopefully, you know, this presentation will be public, so hopefully, you know, we can get them to watch this, and maybe they'll get more motivated.
Yeah, I think like education that would have been also what I would have expected. Like it's something that I'm not sure how much you have done. Like maybe you've already like spent 20 hours speaking with all of them and are burned out from it already. But yeah, educating them, showing them how in quote unquote easy it could be done, or like how much they would need to invest, seems like a well worth investment.
Yeah. Hanadi, you're muted.
Sorry. What are reasons behind the maintainers' decision to keep fuzzing corpus private, non-public?
I haven't, so I don't know exactly with LDK. They're the only ones with the private corpus, and I haven't asked them. But at least for L&D and CLN, I think it was just, you know, they never thought about making it public, or I don't know, because when I suggested it, there was no argument from them. And I was just able to create the new corpus, and there was no pushback at all.
Okay, thanks.
Yeah, Nicholas.
Have you talked to any of the implementations about OSS Fuzz? Like, are they interested or not?
Yeah, so I talked with L&D about it a little bit. The tricky thing is OSS Fuzz is best suited for C and C++ code. They do have, they claim to have Go support, but it's in a very specific way. It doesn't support the new Go native fuzzing engine. And when I looked at how they have it set up, they rely on this library that's not super useful, or not super well maintained anymore. And yeah, so I don't know that OSS Fuzz is best for it. I think CLN could probably use it, and at least if OSS Fuzz would accept a submission from them. But I don't know how it would work with LDK or LND. But LDK runs their own, or at least Chain Code Labs runs their own continuous fuzzing solution for them. So it's certainly possible to do something homegrown. We could look into that for LND as well.
Do you know what specifically they're running for LDK?
No, I'm not sure exactly how it works. Matt Corallo just told me Chain Code Labs runs the fuzzers.
Okay.
Yeah, Gloria.
Hi, thanks for the presentation. I was wondering, mostly for curiosity, kind of how different you find fuzzing for the different languages and setups between the Lightning implementations as well. Like just from a, I don't know, most basic imagination, like whether memory safety is something that you're looking for while fuzzing. Would change, I imagine, from implementation to implementation. How much of it translates?
Yeah. So memory safety stuff is largely a C++ problem. There are classes of bugs that can happen in other languages too, but I think that's the main reason fuzzing really took off with C and C++ initially, and a lot of the fuzzing engines for other languages are all based on libfuzzer. So Rust, if you want to fuzz Rust, then you need some sort of wrapper around libfuzzer that works for Rust. And that's how it worked for Go for a long time too, before they had their native fuzzing engine that they integrated. The Jazzer thing for JVM is also a wrapper around libfuzzer. So yeah, so a lot of the tooling is based on the C++ tools for fuzzing, and yeah, you don't find as many memory safety bugs in other languages, but there's still good reasons to fuzz. Like the LND thing, you can still run out of memory. You can still cause crashes. You can get panics in some languages, things like that are equally bad for Lightning, at least.
Cool, yeah, thanks.
Fabian.
Yeah, I think the presentation is a great start, but I just had the idea you could turn this into a website like the Wallet Scrutiny project. I'm not sure if you're aware of it, but it basically shows a bunch of checks for each wallet. Is it reproducible? Is it open source? Is it self-custodial? So yeah, basically your presentation also shows basically a bunch of checks, right? Of things that are done and how many tests are there. So maybe that's something where you could continuously show that and also show which ones are making progress and which ones are not making progress, or maybe even the opposite, and point people there on an ongoing basis. So I mean, this presentation, if one of them improves, the presentation might be outdated quickly, but having a site to point people to for continuously looking into which Lightning implementation does the best in this regard might be interesting.
Yeah, that's an interesting idea. I'm not sure exactly how to keep it up to date besides manually, but yeah, maybe that would help to motivate the different implementations a little bit.
Yeah, there will be some manual labor involved, but I mean the Wallet Scrutiny project, there's the person that maintains it is funded just for this basically, and so I mean yeah, it's I'm not sure for you or maybe for somebody else, it's an interesting project to kind of just make this more transparent. Yeah.
Yeah, I'd certainly support any work in that direction. Marco.
Hi, yeah. You had said that like chain code for the LDK does like, or they have like 3 tests, which are like state machine test. Yeah. And so I was kind of curious if like you maybe had some link or some information where I could like learn about that. I haven't heard, or I hadn't heard.
Yeah,
Just
so they
what,
have
just like what those tests are and kind of what the like difference is, I guess, between those and just a normal harness.
yeah, they have a fuzz test called their full stack fuzz test. That's probably the most interesting one to look at, where they kind of set up a node and they mock out some aspects of it, but then they start doing things like simulating a connection to the node or a disconnect from the node, or opening a channel or sending a payment, and start mixing and matching these crazy events. Yeah, Nicholas has a link to the fuzz test there. That would be the one I would look at first. Sebastian.
Hello, thanks for the talk. I was wondering about this Decred library from libsecp that you mentioned. Do you know why in the Golang Bitcoin community they re-implement everything rather than using a binding to the official secp library? I think that would make more sense.
Yeah, I'm not the right person to ask. I don't know why. I understand why maybe L&D would use this because it existed and it was easy at the time, but yeah, there's definitely better alternatives in my opinion.
Okay, thanks.
I think I've heard, I don't quite remember, I think I've heard one reason for not using the binding is because it's slower, that like apparently there's some overhead with Seago or something. I also don't know the specifics, but that might be why it's really good. Actually, I also have another question. Since there are no coverage reports, how do you decide what to target, basically?
I do coverage reports myself. There's no public automatic solution available right now, but I will, run coverage of all the corpuses and see what's covered or what's not. Yeah.
Is that mostly on the public corpuses, or do you have like your own that keep growing?
Yeah. So everything that's public is basically the same as what I have locally. Yeah, I've run the fuzz tests enough that it kind of stopped finding new inputs, and then I don't really run them continuously anymore. But that, again, that's something I'd like to see, is some continuous fuzzing. Or like Nicholas, I know you were running some of the CLN fuzz tests on ARM64, and you found a bug doing that. That's something that could be part of continuous fuzzing too, is running on different platforms and in different setups. Yeah, Mike.
For newer contributors, you sort of have a call for contributing and some different ideas for folks that they may see, some of the bugs that you've published or that Nicholas has published and think, wow, there's a way to contribute high impact here. Like, I want to learn about fuzzing. Obviously, they could just kind of Google around and learn high-level fuzzing stuff. But at the point that it becomes, Bitcoin or Lightning fuzzing related learning, like, where would you point those people to go to learn more to be able to start contributing?
Probably the easiest place to start is to just get the fuzz tests running that already exist and run them on your machine. Try different platforms. You can easily spin up machines in the cloud that run different architectures or different operating systems and stuff like that. Nicholas found a bug recently in CLN just by running an existing fuzz test on a new platform. And I think, that gets you some familiarity with the tools, and Then you can start tweaking the fuzz tests. You can start getting familiar with the actual implementation you're looking at. You know, you can generate coverage reports and, well, I think maybe it'd be cool to get some coverage of this area of the code. How could I write a fuzz test to cover that? And that's kind of the process I go through, and I think that that's a good way to learn about this stuff too.
Maybe what's a good place to reach you? That would be interesting.
mattmorehouse@gmail.com is my email currently. That's probably the easiest way to reach out. I'm not on any social media or anything like that. So, but I would just say, you know, I'd really like to see more buy-in among all the implementations. I'd like to see more contributors. If you're interested in contributing and you don't know where to start, feel free to reach out. I'm happy to point you in the right direction. And it'd be great to get more bugs fixed and help to secure the Lightning Network.